So the first part is the top part. We chose a 40 millimeter by 23 millimeter square to start. This allows ample space for the finger to go in, and then we use a circle to cut out, like a 30 millimeter circle to cut out basically space for the finger and also space for foam to go to cushion the finger. We extrude it 20 millimeters because that's a little bit less than the space of the average like top half of the finger. And then I put 3 holes with 3.81 millimeter diameter, right about equal spacing. This is the size of our screws we used, and we put these holes in order to allow for adjustment on where the stopper part will attach to allow for adjustment in rotation, in the angle of rotation of the finger splint. And then we put fillets around just because it looks nicer, and it also is not as jagged as just like sharp edges. Then for the second part, which is the bottom part, the beginning is essentially the same of the bottom part. The top part. The top part and the bottom part, the beginning is essentially the same. But the bottom part has a part underneath that sticks out that is not the same as the top part. This is the slot for the sliding part to go into. So for the sliding part, we chose a 10 millimeter width and 5 millimeter height for it, just because it's smaller but not tiny, at least compared to the rest of the part, and it'll give us a good amount of space for a sliding fit part, but also it not being too bulky on the finger. So, like I said, we made this part that juts out, and then now I'm just making the hole for the sliding fit part. So the slot we did like a triangular shape, or not triangular, but this like wider on the top, skinnier on the bottom shape, so that the piece wouldn't slide out vertically. It would only slide horizontally, like the way we intended it to have. And yeah, the dimensions on that are the same, where it's just made it small enough to work, or big enough to work, small enough to still be neat and clean. Then we made the screw holes on this side, same diameter. The spacing we did 7.4 millimeters apart, just to give more spacing. This piece is bigger, and so yeah, the sliding fit part can be held in place. Once you decide which hole fits your finger best, you can screw it in place, and that'll be the length of it. So it's 6.6 millimeters from the top is the first one, and then the 2 holes are 7.4 millimeters apart each. Then we filleted each of the sides, each of these edges again, just because it's cleaner, it looks better, it's more comfortable. Like I mentioned, this bottom part was longer than the top part. It's 30 millimeters in length as opposed to 20 millimeters in length. It's because pretty universally the bottom parts of fingers are averaging longer, between 1.2 and 1.5 inches. So then for this part, this is the sliding part. We put it into, I forgot to mention at the end that we put we left one wall for the sliding part. It's 2 millimeters thick. So this one is made 28 millimeters to match the length of the bottom part, but then without that wall, because this is going to hit that wall. So yeah, I'm just making the triangular section to match the other one, except smaller, so that we have some tolerance so that it can slide, because when it's 3D printed, it's not going to be a perfect fit, and we don't expect it to work with perfect fit. That'd be very difficult. So we made the top part and the bottom part, or we made the whole thing just a little bit smaller to fit in the hole better for when we actually 3D print it. And then we make the screw hole. This screw hole is the one that will go, you put the screw through this into the bottom part, into the sliding, where those screws are, to hold it in place. And it's the same amount. It's 6.3 millimeters from the bottom hole, which is the same distance that the bottom hole is from the wall. This part is the stopper part. This part, it's like a little U-shaped arm that we use. This is the part right now that is being made to attach to the top part. And then this is the little U. This actually physically stops the finger from bending. And so all of these dimensions that we used, the base part I picked because it's a little bit bulky, but like this part this is like taking force, so I figured that was okay because it needed to be sturdy. Then the dimensions for the U part, it was a lot of trial and error. I eyeballed a lot of it and then just adjusted throughout the process just to see what worked and what didn't. And so these were the ones that came out to work well for us. And then I'm matching the length right there so that it goes across the whole part. And then filleting these edges again, just because it looks better. And then here I'm making the hole for the screw. This part attaches to the top part, so it can be adjusted. 3.81 millimeters again, matching the screw. Can be adjusted, the top part, so that adjusts the angle of rotation. I mean, the sliding part can to an extent, but the point is to make it an adjustable length, and then this adjusting where the stopper connects on the top part changes how much it it's physically able to rotate around the hinge, about the hinge. So this is the assembly. I'm starting with the bottom part and the sliding part. I coincident mated the top of the sliding part and the bottom, or like the slotting part, to have them slide without going through each other, and then I distance mated it inside the capsule. So basically, like, one side of the angled sides to the angled side in the slot. So the angled side of the slotter to the angle slide in the slot. I distance mated them so that there'd be a little bit of gap. And then I limited the distance for the back so that it wouldn't go through the back. And then this is the hinge, quote unquote. The hinge we got from McAllister didn't move. And so I made makeshift little rectangles in SolidWorks, but these were not the actual hinges we used. This was just a placeholder so that I could see the rotation before we actually printed our parts. So I'm just mating them. I coincident mated it and then to the sliding part and then locked it, so essentially like gluing it, just so that it stay in place. It's attached to that, and then I coincident mated to the two edges of the little rectangles, and then limited the angle of rotation so that it acted as a hinge. And so that I could see how the other parts, once they were connected, would move. But again, this is not the actual hinge we used, because the actual hinge we used, the part I got off of the website, did not rotate. Then I inserted the top part. I coincident mated the face to the little rectangle and then adjusted it and then locked it. So again, essentially glued it so that I could just see how the hinge would work, how it looked, and if it actually was, if this piece was actually stopping the rotation at a good angle. So here I coincident mated the faces, the top face and the bottom face, and then coincident mated the holes, so basically like quote unquote screwed it. And then yeah, we can see it rotates. You can see a little bit better from this angle. It rotates and then it'll stop it, and then it slides in and out like that. It'll rotate up and down, and then the stopper part rotates as well. So when it rotates completely away, it's able to do the maximum rotation.